Greetings. In this topic, we are going to familiarize with the Ultrasonic Series by di-soric. Ultrasonic products, though is not commonly applied like inductive or proximity sensors, but it's still important to understand this topic because of its unique working principle and where to use it as a solution. So in order to make use of this series of sensors, we need to know how it functions. Ultrasonic sensors work using ultrasonic wave, meaning sound. So like that, sound waves are sent out. When the sound wave hits an object, they produce echoes. The echoes bounces off the target and returns to the bed. Now in our case, the sound waves return to the sensor. So through this, the sensor can pick up any objects in its detection range, even calculating the distance of the target. And now, since it's working on sound wave, it is not affected by the color, reflectivity, or transparency of the surface. Therefore, when photoelectrics are not applicable to the application, maybe due to surface limitation. Let's say it's glass where light can easily penetrate, or black surface where light reflectivity is not optimal. Then you have an issue in your detection. Then we can consider the use of ultrasonic sensors.
Okay, so here we can have a look at the US series, the Ultrasonic series by di-soric. So for this series of ultrasonic sensors, we have size ranging from M8 up to M30. And by the size, determine the sensing distance of the ultrasonic sensor itself. So the smallest M8 is able to detect up to a distance of 100 mm, whereas the M30 variants is able to detect up to 6 meters. Okay, so right here, so we were saying that ultrasonic sensors emit sound wave. So here you can see the transducer of the ultrasonic sensors, where sound wave is actually emitting from here. And then when there is a target where the sound wave is able to return, then your sensor will switch on. So as we said, even if your object is a transparent one, we will be able to detect due to the sensor being is dependent on ultrasound and not any other working principle. Therefore, it works. Okay, so in the next video, we will have a look at how to operate this series of sensors and how do we configure our sensing area. Okay, so how to configure the sensor? Okay, the sensor is running on 4 wire. We have the brown and blue, which are your positive and negative. Next, we have the black cable. So for the switching version of the sensor, the black cable will be your signal output, either PNP or NPN. So for the white wire, it will be your teaching cable. So right now we have the sensor detection at around this point. Okay, so if you want to set it closer to the target now, so first step, we will put it in front of the sensor. This will be your point A. So your white cable will go to your power, and then you will see the light starting to blink, indicating the start of your teach process. Okay, so now you put it to a particular point B, and then your sensor goes into your positive again. Okay, then you see it blinks twice, indicating that the sensor has been successfully taught. So now when your object goes into your desired sensing area, the sensor will switch on. Okay, so we can have a look again. Point A, positive, blinking indicating teaching has started. Point B, again to the positive, 2 times blink indicating that the teach process is successful. So now the sensor is turning on at this point, whereby it's no longer here. Okay. So how do we switch the NO and NC of the sensor? So currently your sensor switch point is right here. So white cable into the positive voltage for 6 seconds. So you will see the sensor going from green, orange, green. Okay. The sensor is now a normally closed sensor. So when your part entered your desired switch point, the sensor will switch off. So we can do that again. So 6 seconds. Green, orange, green. Now the sensor is a normally open sensor. So switch on, switch off, switch on again. Okay, so for this ultrasonic, what do we have to take note is the blind zone of the sensor. So we mentioned that the sensor emits a sound wave to hit a surface before coming back to the sensor. So the sensor will require a minimum distance, which we call the blind zone, whereby the sensor will not be able to operate. So technically, the blind zone will be about 10% of the maximum sensing distance of the sensor. Meaning, if my sensor can sense up to 200 mm, my blind zone will be 20 mm. If now my sensor is a 6-meter model, meaning it can detect up to 6,000 mm, my blind zone will be approximately 600 mm. Okay, so how do I go about teaching if this is an analog sensor? Okay, so the analog version of the sensor itself comes with both current and also voltage analog signal. Okay, so the sensor will be able to give you both 0 to 10 volts and also 4 to 20 milliampere. So when we teach the sensor similarly via the white cable, your point A will be either your 4 milliampere if you are using current configuration, or it will be 0 volt if you are using a voltage configuration. So when you teach point B, it will be your 20 milliampere or your 10 volts, depending on your selection. Okay. So through this, we can teach a further distance as your point A. So this will be your 20 milliampere, sorry, your 4 milliampere or your 0 volt. Then point B, this will be your 20 milliampere or your 10 volts. So depending on your selection, the sensor will scale accordingly. So similarly with the switching version, 6 seconds will toggle between normally open and normally closed. So for the analog version, 6 seconds will toggle between current and voltage configuration. So that is how you go about configuring the analog version.
Now we have a look at some featured technical functions of the sensor. This series of ultrasonic sensors are IO-Link integrated. Therefore, we are able to configure the sensing parameters not just via the wire, but also through IO-Link software, where there are more selections of parameters and the inputs can be more precise. The sensor comes in two variants, switching and analog version. So if we only need an on-off sensor, we can go for the switching model. Now if your application is level measurement, distance calculation, or others which requires an analog output, then we can go for the analog model. So you can see the sensor is very easy to set up and adjust, either via wire teach or via IO link. Then it's able to be taught either a point switching or a window switch, meaning my sensor can turn on at one specific point, or if I want my sensor to turn on between point A and point B, then I'm able to do that via the teach process. Okay. So one very important thing to take note is that for this switching model, it is a push-pull sensor, meaning it can work either in a PNP or NMPN configuration. NO and NC are selectable as you have already seen in the tutorial video. Now the analog models give you both current and also voltage output, meaning if you need 4 to milliampere or 0 to 10 volts as your output, it is fully configurable. So what does this mean? This actually gives an advantage whereby we and also the customer will have no problem in selecting the model required. We just need to know if the application requires a on-off signal or a analog signal, then everything is in one singular sensor itself. So other than this, we also di-soric is also developing the narrow beam models, and then currently the M12 is already available for sales, and the M18 is in development. So what does the narrow beam model give you? The narrow beam model actually has an added feature at the end of the ultrasonic sensors, and it controls the emission of the ultrasonic wave. So the beam is much more narrow. So if let's say your application there are difficulties in accessibility of the ultrasonic wave, or that you are trying to detect a component that is uh, smaller in dimensions, then we can always consider to use the narrow beam models. So what are some of the key selling points of di-soric ultrasonic sensors? Right now we have our own ultrasonic development, meaning di-soric has full control over its product development and also price positioning. So in the event whereby we have a potential project for ultrasonic solutions, then we have a lot of flexibility to talk about. Okay, next, for housing designs, and we have a lot of options when it comes to housing dimension. So from the smallest M8, which is unique in the market, up to M30. Then one strong point about the housing is that the housing length are relatively short. So right now, when machine dimensions are getting smaller and smaller day by day, this is definitely an advantage. Then we do not have a big number of competition in the market, i.e. to say we are very competitive in this area. Last but not least, we are both CE and UL certified. So this makes the ultrasonic series much more appealing. definitely so for medical facilities and also for machine exporters. Okay, let's now have a look at some of the di-soric ultrasonic models and what advantages do they bring about. So first, we have the US-08. So the US-08 features a M8 cylindrical housing, which is one of the smallest in the market. The small size is an advantage, where short distance sensing is actually applicable and the installation space is limited. Next, we have the USQ12. So as you can see from the photo, the USQ12 is a cuboid design with a 90-degree projection. Therefore, unlike its other cylindrical counterparts, the sensor is installed differently and this provides additional mounting flexibility. And for both the sensor, the blind zone is only at 20 mm, which is relatively small. So last, we have the US 12. Okay, for these variants, you can see that there is an additional feature at the end of the sensor. So this is the narrow beam variant of the ultrasonic sensor. Now this design actually allows the sensor to perform precise point detection and overcome any problems when the regular ultrasonic wave is too wide to carry out its inspection. So as we mentioned, this additional cap at the end of the sensor actually controls the projection of the ultrasonic wave to make it more narrow. Now some application examples where ultrasonic sensors can actually be used. So of course, as mentioned, transparent objects that are not reliably detected by photosensors, then we can consider the use of ultrasonic sensors. Next, we can use it in hoppers to control the level of materials that is currently in the hopper itself. Okay, next we will see a video of an application using the M8 ultrasonic sensor. So the M8 ultrasonic sensor is installed right here. So the user is a medical pills manufacturer. So some strip of pills are bundled together and the sensor is used to count them as they are being transported using the conveyor. So far, we have seen a lot of diffuse ultrasonic sensors. So other than those, di-soric also has ultrasonic true beam sensors, an ultrasonic sensor in the design of a fork. These variants of sensors are referred to as web edge sensor. So generally used in web guiding system to ensure the materials are positioned correctly for processes such as packaging and also printing. So here we can see the material. So as the material passes through multiple rollers, there is definitely movement towards its left and right limits. So the web guiding system will react accordingly, bring the material back to its center position. So using the analog signal from the ultrasonic fork to control and ensure that the positioning of the material is accurate for its next process. So in regards to certification, the series of di-soric ultrasonic sensors are both CE and UL certified. That is all I have for the topic on ultrasonic sensors. I hope that through this presentation you will gain extra information on what are ultrasonic sensors, where we can use them, and also other additional knowledge which will be useful to you. You can come to me anytime you need any clarifications or more information. Thank you for the time and effort. I wish you all the best.